Okay, today is Thursday, October 28th, and in this particular session I'm going to be taking a look at EIGRP. This is going to be a really simple, straightforward EIGRP, single AS. Not going to dig too deep. This one's kind of taking it probably at like the 50,000 to 75,000 foot area. We'll look at how configuring the bandwidth modifies the EIGRP metric that is the result of the dual calculations, verify EIGRP adjacencies, look at the routing information that's exchanged, turn on the debug commands, but also in addition to the debug commands, should actually put in there, I'll also be using Wireshark captures. While the debug provides really detailed information, the captures go even deeper, and there's information that's in the capture that's not readily available in the debug message. And then we'll take a look at how convergence occurs. What you'll see, actually go ahead and switch over. So you see, and make that a little larger. That's the topology for this instance. Bring that network down. Pretty straightforward. You have routers 1, 2, and 3 connecting into a VLAN and a broadcast network, VLAN 1, on that 10.1.100/24 network. Then there is a serial connection between router 1 and router 2 that plays into convergency in multiple paths. What we're going to see is that router 3, once is configured, router 3 will actually have two paths to get to it will have two paths to get to the 10.1.200 network. And what we'll then do is we're going to make one of the paths go away and see how quickly it takes before the communication is returned. So again, it's really straightforward, really simple, straightforward configuration here. I think I've already done the IP addresses, show IP interface brief. Again, this is EIGRP for IPv4. So yeah, the IPv4 addresses on the fast Ethernet 0/0 up and up. That's for the 10.1.100.3, and the loopback 3 10.1.3.1 is in the up and up. And these loopbacks are simulating LAN segments in the network. Go take a look at 2 here, show IP int brief. Okay, and the up and up state, the 10.1.100.2, which is into that VLAN 1 broadcast network. Oh, I know. The other thing we're going to see in this is that because in the broadcast network there is a particular feature of EIGRP that when we look at the neighbor relationship, we won't see that when we look in the neighbor relationship on the serial. I'll make sure to point that out. So we're good there on router 2, and show IP interface brief on router 1, up and up. And just make sure that we can ping through to 10.1.100.3. Alright, isn't that? Yeah, well, okay. Make sure here we can ping through to 10.1.100.1. And .3. Just making one of the things in GNS, for me, I always make sure that I have verified connectivity. I've had instances in GNS3 in my particular case where the connection was showing in the up and up state. However, ping or any actual communication was not passing. It's rare, it occurred, and it actually made me kind of lose my mind for a little bit because I'm looking at it in up and up, and come to find out that yes, while it was in the up and up state, there actually was no communication on that line. So we've got the interfaces configured, and think with that we can actually just go ahead and jump in here. Again, EIGRP, let's see, let me bring up, I think I have it over here. Yeah, drag this over. This is from Cisco's website, and what we're going to do just is look at EIGRP features. There's the URL. This is just from the iOS-XML iOS IP route EIGRP. You can find any number of sources, but I'd just like to start with this particular link. Some of the EIGRP, which most of us know is Cisco's proprietary / element made open source with the back in 20, I think it was 2013. So it's a EIGRP RFC, because I don't think it's an RFC. I think it's a EIGRP. There's the Dan Savage. Scroll down, roll. Right. Okay. Make this larger. So back in 2013, there was a portion of the EIGRP that was made open, that was opened up, and I'm sure there's some real reasons, some other reasons why this was done. I'll keep I have my own theories, but I know that there are a number of engineers that I've spoken to believe, well, if it's going to be made open source, it should all be made open source, not just a portion of it. For me, it is what it is. There's an element of EIGRP that's now been made open source. The RFC, and it's not an RFC. It's a draft. For some reason, my mind is completely leaving me on the word of what this is, because okay, here's the document describing EIGRP. SRI International did the testing. Terms, lots of terms. That's one of the biggest hurdles on EIGRP to start with. It is a language in and of itself, and it is critical. It's been critical for me to call attributes of EIGRP by their name repeatedly, and you'll see what I mean when we actually start looking at some show commands from show IP commands and looking at the EIGRP output, because calling things by their name, one, reinforces it and helps build additional interconnections. So that's enough about that. Let me go back here. Fast convergence. I remember my very first Cisco training class. I'm trying to remember if I think that very first class, that very first class, which was, let me look at something real quick. Cisco, CISCO, EIGRP introduced. Before there was EIGRP, which stands for Enhanced Interior Gateway Routing Protocol, there was IGRP. And I'm going to take a look and see. Let's just see what Wikipedia tells me. I believe that when I took my very first class, so my very first class, EIGRP, we did have EIGRP, but I believe in that class we actually had IGRP 2 for some reason. That would have been 1997. Chesapeake Bay Networks, that was my trainer, and it was the Cisco routing, the first class. So, but there's the EIGRP page. I'm jumping around too much. where I was headed with that is fast convergence. That is the Bible of EIGRP, and that fast convergence comes out of this capacity of EIGRP to maintain multiple paths to a destination and have those paths in the ready, nearly waiting to be cut over to be put into production and active use. That's the big piece. Another aspect is partial updates. What we have is in the beginning using the different EIGRP messages to actually form the neighbor relationships and the adjacency. After that, the only data that's transmitted are changes in the network. So here it says EIGRP. Let me make that bigger. Oh, funny. Okay. Firefox may have just frozen on me. Oh, there it goes, finally. Is that partial updates. EIGRP sends incremental updates when the state of a destination changes instead of sending the entire contents of the routing table as our old friend RIP and RIPNG do. And this is a feature that minimizes bandwidth required for EIGRP. The neighbor discovery mechanism, we'll see the neighbor discovery mechanism coming through, being referenced, shown in debug commands as well as in the wire captures, which Wireshark captures, and scaling. I've seen some really large networks that use EIGRP. I've also seen some incredibly large networks transition away from EIGRP to OSPF. I think the case for what routing protocol is selected has to take into consideration needs. Needs drive the decision. That's, the emotion, put that aside, and I think that's what we see with most engineers. The engineers simply want the solution that is going to result in the highest performance and the highest throughput / the fewest incidents for breakage and 2 a.m., 3 a.m. calls. That's all we care about. We want it to work. We want it to work consistently, and with EIGRP, you will indeed have all of those. In fact, everything that we're covering, that I'll be covering in these YouTube sessions, works. Works fantastically. However, with all of these, knowledge is key, and knowledge is the capacity to extrapolate and extract from information present what is broken. And I'll be doing T-shoots. I'll be doing some T-shoot activity as well. Not a lot, but, well, then again, I might. Maybe I will. I'll do more. Okay, so that's just kind of the big picture there of EIGRP. It uses that autonomous system number. I'm just going to scroll through. EIGRP named mode works really cool. Allows for, instead of using an autonomous system number, there's a name that's actually assigned to the instance, and that brings in address families, which we'll be seeing with using address families when we're running EIGRP for IPv4, IPv6 in a stack. We'll use named mode and address families. Neighbor relationships based on the hello message, that's the kickoff. I think we'll do some authentication in another session, maybe even in this one. The dual finite state machine, that's the dual that actually performs the calculation that results in on a local self-seeing from the router, let's say from router 1's perspective here. The dual results in a computed distance, whereas the information seen on router 1 transmitted to it from router 2 or router 3 is the computed distance, the reported distance. So computed distance, reported distance, and then there's a feasible distance. So we'll be seeing all of those. And let me go ahead and jump in here. So we've got the connectivity. Again, this is going to go pretty quick. Let's see, right here on router 1, let's go ahead and do debug EIGRP packets. Should see probably nothing. And go into global configuration mode, which is I type in conf t for configuration terminal, configure terminal, exit just to show. So conf t accomplishes the same thing. Router EIGRP AS1. Network statement says what interface, look for the interface that has this particular network associated with it, and that's the network to start sending hello packets out. That's what it says. And what we see later in some other options is that we can actually say under the interface, instead of using the network statement, we can activate EIGRP as well as OSPF under the interface. So here we're going to say network 10.0.0.0, and we'll look, we know that 10.0.0.0 effectively says turn on EIGRP on router 1 on all the interfaces that begin with 10. So that will be the serial interface as well as the fast Ethernet. Now you notice that back here, nothing, debug is on, but nothing has happened. That is about to change. As soon as I type in the network command, the first hello went out, fast Ethernet 0/0. Now, we can't see the hello going out on the loopback interface that's configured. To see that, we would need to say do show, I'm doing this from within global configuration, so I'm using the do command, do show IP protocols. Oh, actually, no, wrong command. Do show IP EIGRP show IP EIGRP yes. Right, I'm breaking myself. Let me stop. I know what I want to do, but I don't want to do it here. I didn't turn off, so the hellos are still flowing. We have EIGRP configured on router 1. We've got the hellos going out. And it's that hello message. So what I'll do is real quick, I'll just do a capture on router 1 on this serial link, and what we'll do is we'll take a look at what's actually happening and what a hello message looks like in the capture. And it only takes just a couple of them to get a sense of this. And the reason I want to take this little time in here is because it's actually, this is a quick walkthrough. So let's see, Wireshark. Did Wireshark not come up? Let's try it again. Stop capture. Start capture. Serial HDLC, router 1, and go back over here. Kill that session because that one didn't work for some reason. Okay. Okay, I'll take a look at my Wireshark analyzer later. One is set up. Let's go ahead and go over to router 2. And we're going to repeat the same steps. Host name is already configured on all these routers. The networks are up. And we're going to say router EIGRP. And we're going to give it an autonomous system number of 1. And we're going to say network. Again, 10.0.0.0.0. And almost immediately we get a neighbor change for EIGRP for IPv4 with AS1. Neighbor is at 10.1.100.1 via the fast Ethernet 0/0 is up, new adjacency. And we would have much more detail in here. Actually, I do. I know what I can do. Stop. Start a capture. I actually have a hello message from EIGRP already saved, because I do want to see that hello message before I move forward, and there's a reason why. And I can just look at some previous, see, OSPF, redistribute, EIGRP. Named mode summary. Okay, I guess not. I'm sorry, I'm wasting my time. I'll come back to that though. So we now have on router 1 and router 2, we have an OSPF adjacency. And if we go back, there's a lot of detail. I should have. Okay, here's what I'm going to do. Say no network, and say, and then return the statement, because I want to get here. That's what, and say adieu you all as soon as I see the next the hello messages starting. Okay, we can do it there. So as a result of that, okay, so here was me shutting it down, sending hello, received a hello from neighbor at 10.1.100.2, was sent a hello on the fast Ethernet, received an update on fast Ethernet, received an update from 10.1.102.2, sending an update to 10.1.100.102, and going through that whole, just kind of finally the neighbor relationship forms, and then these messages pass back and forth. The neighbor change, the neighbor adjacency change occurs immediately upon seeing the hello messages, and then there's the exchange of data, which results in the EIGRP going into a state where if I say do show IP EIGRP neighbor, we see that this neighbor here, this is the handle, that's the order in which the neighbor relationships come up. So handle 0, which is in this space, is the first one. That's the IP address for it, the interface, the hold time, the uptime, smooth round trip time, retransmit, and this is always, we always want to see queue count 0. Sequence number is 6. So we've got an EIGRP neighbor relationship there between router 1 and router 2. So let's go ahead and back up. We're going to say show IP EIGRP interfaces. Okay, remember when I said earlier that we were entering it very loosely using a network statement of do show run section EIGRP. Oops. Do show, yeah, okay, now we should be, where I used a very loose statement just of that network statement of 10.0.0.0. And if you see here, that did indeed enable EIGRP, this for on loopback 1. So we're looking here, it says EIGRP IPv4 interfaces for AS1 for Autonomous System 1, and that is the interfaces of Fast Ethernet 0/0 and loopback 1. Okay. So I'm not sure, as I'm recording this, my dog is a beagle, and she follows me everywhere. I have a strange feeling right now. You can hear her snoring. That's not a person. That's actually Junebug snoring. Yeah, now she's gonna stop. Okay, so I'll continue. I'll pay that no attention. If you can ignore it, I will. So we're that the show interfaces. There are three tools that are readily available to us. We have the show IP EIGRP neighbor. We have the show IP EIGRP interfaces. We have the show IP EIGRP. Let's take a look at those and so we can see. We have, so it's interfaces, neighbors, and this one's really good, topology. Topology. Not going to go too deep, but remember that I told you about there's that feasible distance. This is the reported distance, and this is computed distance. These are calculations that are a result of the dual algorithm, which is a fairly complicated algorithm, but that when if the default values are maintained, it will, I'm looking for the word, it will be not reduced, but the equation comes down to bandwidth plus bandwidth times 256. And let me see, I can bring that up. Let's see, EIGRP. I can say, let's see if we see their metric weights. That's talking about mismatched K values. Let's see if I can say. Oh, I think that was it. No. Okay, I'm not gonna waste more time. Oh, there we go. Now that's looking at the IP protocols. We'll be looking at the dual algorithm and working with those calculations in detail. So let me bring back the topology, bring back the routers. So we've got, again, three tools here: show IP EIGRP interfaces, show IP EIGRP neighbors, and show IP EIGRP topology. And let's say we're gonna do, I think what I'm gonna go ahead and do, okay, so I really want to see what's going on. Let me take a look here. I think what I just need to do, I want this, let's see, PS minus EF. What I'm doing is I want to check and see where my Wireshark, why it's not coming up. I think the process is already, yeah, there's a process already, it's hung. So I'm going to kill minus 9, 5521. Okay, that, oops. Oh, I know what I did. Wrong number. Yes, minus EF, grep, Wireshark. Kill minus 9, 5599. Hmm. 5663. Okay, that should have done it. For some reason I have a Wireshark process. I'll kill it over here. Bear with me just for a second. Actually, I'll just bypass that for now. Okay, so we'll go back to where we were, which was looking at the EIGRP adjacency between router 1 and router 2, and this is the adjacency in the broadcast segment with that VLAN 1 broadcast. So when we look and say show IP EIGRP neighbors and show IP EIGRP, what else I want to take a look at? Let's see. I want to look at my notes here. Let's see, show IP, I'm drawing a blank here. Okay, we looked at topology. Show IP, EIGRP. Look at the AS. We've looked at it interfaces. I think I'm okay for now. Okay, so we've got that. Show IP EIGRP root. Let's do that. Show IP root. And we see at this point we've got one route that's been learned already, and this is that loopback interface, that loopback 2 interface on router 2. So see it's designated right there. That D does not stand for designated. That D stands for it dual. If we go up here to the legend, you'll see D-EIGRP. And if we come back and so we're going to go ahead and set up EIGRP on router 3, going into global configuration mode, router EIGRP 1, and we'll say network 10.0.0.0. Should be almost immediately we get the 2 adjacencies. The first is with the adjacency with router 2, and the second is with router 1. 10.1 is router 1. 100.1 is router 1, and the 100.2 is router 2. Okay, and so we're just going to kind of step back through, and we'll verify the configuration. So we have full configuration now between routers 1, router 2, router 3 with EIGRP. So we'll now take a look at that. So show IP EIGRP neighbors, and there we see again that handle, which is the order in which the neighbors occurred. So router 2 was our first neighbor because its handle is 0, and router 3 is the second one. And there's the interface hold time, which we'll be taking a longer, deeper look at as we move forward. Uptime, the amount of time that the neighbor adjacency is up. Smooth round trip time, that's what that SRTT stands for in microseconds. Round trip time. Q is for Q. The letter Q stands for the word queue, as in waiting to be processed. And the sequence numbers. So there we've got that on router 1. And let's just move on. We'll look at it on router 2. Show IP EIGRP. Show EIGRP neighbors. Okay, and there we go. We've got it. So we're seeing router 3 and router 1, the interface, which is the fast Ethernet interface, and again stepping through the interface, hold time, uptime, as we would expect. The handle for router 1 is 0. That one's been up for 35 minutes, and that's router 3. And go take a look real quick. Show IP EIGRP neighbors. Okay, so we've got our full neighbor relationship set up there between routers 1, router 2, and router 3 over that VLAN 1, that 10.1.100. That's that broadcast network. And now what we're going to do is we did a moment ago here, we did the show IP route, and I'm going to give it one additional part of the command, show IP route EIGRP. So we're only going to see the routes now that have been learned by EIGRP. So from router 3, we've learned the 10.1.2.0 network, which is the loopback interface on router 2. And we've learned the 10.1.1.0/24 network, which is on router 1. So let's go take a look. We'll go back and we'll do the same thing on router 1. Show IP EIGRP route. Whoops. Show IP EIGRP. Show route. Got my commands by show IP route EIGRP. And we've learned from the dual, we've learned about the loopback interface on router 2, and we've learned about the loopback interface on router 3. And there's the so we've got that network, and indicating very clearly here that the 10.0.0.0/8 is a variably subnetted network. So that's important, and we'll be looking more at that as I move forward. So I should be able to ping those loopbacks, and I'll just make sure that we can. So from router 1, we're going to ping 10.1.2.1, and I can. And ping the loopback on router 3, 10.1.3.3.1, and I can. Great. So we've got the connectivity in the broadcast segment. So now what we're going to do is we're going to set up EIGRP on the serial link between router 1 and router 2, and it's much the same as it was in the setting that up in the broadcast. The configuration is the same. So we're going to go into interface serial. Let's see. Well, let's do this. Do show run interface serial 1/0. Oh, wow. So I haven't set up the IP address on here. Well, let me do that then. So we're going to say interface serial 1/serial slow down, IP no shut down, IP address 10.1.200.1 255.255.255.0. I'm going to give that a clock rate of 64,000. Go ahead and write that. And just go ahead and jump over to router 2 real quick and configure that. Do show run serial S1/0. If I didn't configure that one either. Okay. Interface S1/0. No shutdown. IP address 10.1.200.2 255.255.255.0. Do write mem, or it could do copy running config startup config. And let's make sure, see that we have exit. Do ping 10.1.200.1. Make sure that we have connected. We've got connectivity to that serial interface from router 2. Let's make sure that we've got that same connectivity from router 1 to router 2. 10.1.1.200.2. .1.200.2. Did I say no shut? Do show run interface brief. Show interface brief. Show IP int brief. Serial is in the up and up state. 10.1.200.1. And what did I say? I typed it should be 10.1.200.2. Well, I'm surprised this actually worked. I crossed up my IP addresses. This address should be yeah, let me fix this. What happened here is I've actually used I like to have the addresses align with the router number in the lab setting, and here I assigned the serial interface the IP address for serial should be 200.2. IGRP 200.2. Okay, there we go. So changing that, because that's now 2.2. Make sure I've got the address down here correct. Do show run interface serial 1/0 on router 1, and that is 200.1. Okay, so now we're good, and we actually see the neighbor relationship has come up already. Now if we do on say show run show interface serial, let me type it out, interfaces serial 1/0, we can see here there's the address that's assigned to it with that 24-bit mask, encapsulation HDLC, but what's really important for EIGRP is this line right here. Not so much this one. We're going to find out something about this during the course of the sessions, that there's a theory out there, and I was actually taught this in a class back in the probably like 10 years ago. It was actually in a session where the instructor actually taught that MTU was used, and the MTU value was used in the dual calculation. And we'll actually look for that when it comes to it. But the values that I know up front that are going to be used in the dual calculation are bandwidth and the delay. And these are values that are involved in the metric calculations. They do not in any way actually affect the physical network line speed of the interface. There are changes in values that the protocols use for calculation purposes that affect the metrics, that affect the troubleshooting data that we have to look at, but they in no way actually affect the line speed of this segment. So we see there that the serial 1/0 network on router 1 has a line speed of 1544, so it's effectively at a T1 speed. And why this is important is that EIGRP by its default will use 50% of the bandwidth in an interface for it will use, I'm sorry, it's trying to stop a message from coming in here. By default, EIGRP uses 50% of the bandwidth of an interface to flood out its routing information. And so 50% of a serial might not be so bad if the traffic on this T1 link was insignificant enough that we wouldn't notice it. But if this was a T1 that was running, let's say running at 80% capacity, and there was then the router to start, the EIGRP to start populating and flooding at 50% of the capacity, we would then lose 50% capacity for the traffic that's not protocol related. So it's important to understand how we can manipulate EIGRP to use less of a portion of a segment for its flooding out those limited updates. Remember, it's not sending out the entire routing table. It's only sending out a portion for changes. But if there are enough changes occurring, or if there's a flapping segment, then we could have a lot of activity that really would impede and affect the performance of the network for what the end users were seeing. So what we're going to do here to play with to kind of drive home this, we're going to go back into the serial interface 1/0, and we're going to change the bandwidth. And what I want to do something. What is it I want to do before I do that? Oh, I know. I want to say do show IP EIGRP topology. Okay. And what we're going to see is how I'll do it. Oh, we'll do it here from router 2. Do show IP EIGRP topology. We're going to see how the values from router 1, which are these 10.1, is right here, this feasible distance. We're going to see that this value and the reported distances from the neighbors from router 2 and router 3 as they report to each other will change for that once we change this calculation. So once we change this bandwidth value. So we're in interface serial 1/0, and we're going to say bandwidth 64K. And so we can see that what it says bandwidth, enter it in bandwidth in kilobits. Okay, so I entered 64. And now we're going to in there and go over to router 2. Make sure I'm in the right place. Serial 1/0, bandwidth 64. And if we come back here to router 1 and say show interface serial 1/0, you see that bandwidth value has now changed, whereas before it was 1544, now it's 64. Now what I want to see is, I'm going to stretch this up as I think I should see it. Let me make sure. Get a little bit. Okay, let's see. 15616, 128.256. Yeah. Okay, so let's take the first one here. So if we look now that this is on router 2, and router 2 looking at the 10.1.200 network, we see that now we have a feasible distance of 405.12.000. Previously, before I change the bandwidth, that feasible distance to that network, to that 10.1.200 network, was 216.9856. So we see the feasible distance resulted in a dual recalculation. And later, once I have resolved my Wireshark matter, we can actually see the network going into a what happens when it's doing the recalculation. So we see that one change. So let's see, for the 10.1.100, that's 2816. 10.1.100, still 2816. So the only one that changed was the successor to 10.1.200, which is the serial interface on via the serial 1/0 interface. Okay, so that's what we can. That's just a brief touching on changing bandwidth and in this case delay to cause a recalculation of within dual so that we have new feasible distance. So let's see. Next, we want to take a look at. Okay, we've already looked at the neighbors. And now let's see, I can't remember. Let's see, show on router 3, show IP EIGRP neighbors. And there are our neighbors of 10.100.1, which is router 1, and 100.2. And show IP in brief. So I need to add in a couple of more loopbacks on router 3. Interface loopback 11. IP address 192.168.100.1, 255.255.255.252. Okay, so we've got that loopback interface on that one, and now we're going to say interface loopback 15, IP address 192.168.100.5, again giving it a 30, subnet 255.255.255.252, and exit. And now what it's going to be interesting is, okay, I've put those interfaces in those loopbacks up. Do we see them? If I do a show IP route, do I see any 192 or 192.168, those two networks, 192.168.100? We're only seeing, the only thing we've seen that's been learned by dual, so to narrow it down, we'll just look just at the IGRP. We're only seeing the 10.1.1 and the 10.1.3. So what we actually have to do is we need to put those interfaces in to participate in EIGRP, and right now they are not participating in EIGRP, and it's just a matter of we'll add those particular networks to the EIGRP process on router 3, and we will then we'll get them actually participating. So what we'll do is go back to router 3 and say router EIGRP 1, and the network statement 192.168.100.0, and the wildcard 0.0.0.3 for that /30 mask. And let's just do a quick, show IP EIGRP interfaces. Okay, sure enough, there's the loopback 11 is participating in EIGRP now. And let's go back, and so now when we go to router 1 and we'll say show IP route, oh, sure enough, now dual with EIGRP is showing us that 192.168.100 network. So we've got that. What else I need to do in here? Oh, yeah, let's take a look real quick. Show IP protocols. Get all that information rolled up the screen. So this is a good one also as a reference. We see that EIGRP with process ID, and make sure that if you have ever any doubt, router EIGRP, what is that? It's the AS. I set process ID. I need to get my mind clear here. I've been working in OSPF for the past week. So we have this AS for this EIGRP instance here. This is EIGRP for IPv4, AS1. The metrics weights, which are the K values, the K value 1 and K value 3 are set. K1 value is for bandwidth, K3 is delay. All the others have a value of 0. The router ID is 10.1.1.1. We're going to change that. That's why I wanted to go in here. So we're going to go back into the router EIGRP1. And I'm going to say EIGRP, and there we go, router ID. I like to explicitly assign the router ID so that it is, I can tell which router I'm getting information from. And so by saying router ID 1.1.1.1, keep in mind this is going to bring down the adjacencies and bring them back up. So this is not a simple configuration change. It's a change that was going to cause an outage. Notice nothing happened right away. If I say do show IP protocols, so the router ID 1.1.1, it's changed, and see there are those back there behind those. It did come down and the adjacencies did come back up. So this is definitely an action to take care of early in the configuration process, or if it's a change that needs to be made during scheduled maintenance outages where production activity is not impacted by it. So go back, show IP protocols. So we've got the K values, the router ID, the networks that are routing for the networks 10.0.0.0, and our gateways and our distances. And the internal administrative distance is 90 for EIGRP, and the external is 170. Let's see. I think what we're going to do is real simple. I'm going to look at from router 3. If I do a show IP route, EIGRP has learned that to get to that 10.1.200.0 network, which we know is the serial network, the serial segment between router 1 and router 2, it has two paths to get there. Equal cost. It's identical. So now if I say do show IP EIGRP topology, so here we have, it's a good chance to go through this briefly. It's in a passive state. We always want to see passive, meaning that there is the network EIGRP has learned its roots to that direction. It's not now still attempting to go be active looking for a route. So to the 10.1.200 there are two successors, and the feasible distance is this 405.14560 number, and both routers have the exact same the computed distance and the reported distance to that. So what we have is that from router 3, if I say back out and say ping.10.1.200.1, and then I say trace route to 10.1.200.1. Okay, notice it's going using both paths. It's going 100.1, 100.2. So it's using both paths. 100.1, as we know, is through router 1. 100.2 is through 2. So what I'm going to say would do is we're going to say ping 10.1 repeat 10,000 times. Okay, then we're going to jump over to router 1 and shut down that fast Ethernet interface FA0/0, shut, and go back to router 3, and we see there's one packet lost, 2, 3, 4, 5. It's going to take it a moment here, but it will cut over to using the other segment. There we go. Cut over to using the other path. We saw that the hold timer finally expired for the fast Ethernet over to router 1. And this is just part of what dual does and how we can configure EIGRP to have topologically multiple routes to a destination, and the routing protocol will maintain those routes, and we can tweak it so that they are the cutover to a failure is instantaneous, almost instantaneous. This again is GNS3, so I can break out that. This is GNS3. In an actual production environment, we could tweak this to the point where to end users it would be almost unperceivable that there had actually been a loss of a segment there. So I think that is all I want to do in here, because we've got EIGRP up and running between the routes, and we'll be going deeper, but that's the basics of getting EIGRP running with, say, show run section EIGRP. So we get the EIGRP process running with the router EIGRP1, where 1 is the autonomous system number, and we define the network with the network statement 10.0.0 or the network.192.168. We'll see that actually we could go under interface fast even at 0 and say IP. I'm curious, I'm looking for something. No, I'm not going to do that. I'm getting ahead of myself. So I think that's where that's a good place to stop. Back to the topology. We have EIGRP running and the broadcast network between router 1, 2, and 3. We also have EIGRP running on the serial segment between routers 1 and 2. And there is one more thing, and I'm not show IP EIGRP show IP let me look at I know what I'm looking for, but my mind is going absolutely blank. for the commands. I'm gonna look back at my notes. Oh, where show IP. Ah, now we go. Show EIGRP protocols. Okay, that gives me, which is a subset of the information from the show IP protocols. Show. Oh, I know. I'm good. My mind is still in OSPF mode, and what I was looking for was an OSPF related concept that is not an EIGRP concept. So that's it. That's actually the good space. Just going to look back through. We configured the networks. We have EIGRP running. In the show IP protocols. EIGRP, AS, the K values, the router ID, the timers, path, variants. We'll use variants later. Oh, automatic summarization is disabled. In earlier versions of iOS, auto summarization is enabled by default, and we have to turn it off. This is a 12 dot show run section version. This is a 12 dot show version section version. This is 12.2. So I think in going back to like 12.3, maybe 12.2, auto summarization is on by default, and that needs to be almost always turned off, because auto summarization turns everything into a classful network, and that's fairly impractical in most modern networks. It is possible that there's a small enough entity that the network is designed around a classful boundary. In that case, it wouldn't be a problem. However, in a larger corporate enterprise network, running on a classful boundary would almost be impossible to maintain. Okay, so that's where we're going to stop. In the next session, we're going to take a look at EIGRP load balancing. And so we've got 1, 2, 3, 4, 5. We've got several more for EIGRP. And these are great. Again, these are just my review sessions for me. Information that you're seeing is as is. No warranties. Can't verify that what you see here would work in your environment. This is all in a lab setting, so I can break it and be back in working, have a restore and back working within minutes. Or in a production network, some of the changes that I might make could cause outages that would have repercussions that were catastrophic. So I'll be back with the next session in just a little bit. Take care.